So you should look at part 1. If you haven't, we did translations, and we're going to continue translations. So again, translations are just a shift, right? We're just moving them. We're moving them vertically, or we're moving them horizontally. And we have our parent function. And you should know certain parent functions. So this parent function we went over last video. It's f of x equals x squared. It looks like this, right there. Right? In the last video we said it looks kind of like psi, right? The Greek letter psi. And that's it. It's a U-shaped quadratic. And if we put this, if we said, let's say, we'll just make that g of x. Let's say another function. And we have g of x is x squared minus 3. So here's what we want to do. This is what we want to translate right there. And say it's minus 3, so we want to go down 3. 1, 2, 3. We're going down. We're shifting down. And there it is. And we did that in the last video. But what if, let's say now, we have something like this. Well, we have our parent function, f of x equals x squared. But there's an a here, and a means that we have a number. And in this case, it's 1, so we can just put x squared. So we can just say f of x equals x squared. But there isn't the a. This is just what it looks like if a is 1. Now, if a is 1, this is the parent function right there. If a is 1, like we did. But if a is greater than 1, the graph is going to get narrower. Right? So here's an example right here. We'll just use g of x equals 2x squared. So whenever a is greater than 1, like here we have 2, the graph will get narrower. Right? And let's explain why. So let's just say that let's say x is 1. Right here, x was 1. When x is 1, 1 squared is 1. So it would be right there, which we see. If x is 2, 2 squared is 4. It would be right there. So that's if we had f of x equals x squared. And if x is 2, 2 squared is 4. 4 times 2 is 8. So when this would be way up here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So when x is 2, it's up here. So you can see when it's greater than 1, as we see here, this is just a rough graph. When a is greater than 1, in this case 2, it will get narrower. So guess what happens when a is less than 1? It'll get wider, right? So if a is less than 1, like 1/3. So again, here's our parent function. We had f of x equals x squared. But if we have a now being 1/3, because it's less than 1, then this graph will get wider. It'll get wider. So just a review. If a, the a term right here, is 1, then it's just going to be the normal graph. If it's greater than 1, it'll be narrower. And if it's less than 1, it'll be wider. Something to memorize. Now, before we go further, I want to look at vertex form, not vertical form, vertex form. Vertex form. And we went over vertex form before also. So this is what vertex form looks like. And here's the general format. So we can take let's put a trinomial into vertex form. So we did it right here. So let's do that. So here we have, in standard form, we want to get the vertex. We found the axis of symmetry. This is the formula. You know this already. So we have negative 6, which is just 6, over 2a. In this case, a is 1, so it'll just be 2. And we have the axis of symmetry of 3. And we just plug in 3 to the formula, 3 squared minus 6 times 3 minus 7. And we get this, negative 16. So we can put that in vertex form. Here it is. We're saying that the vertex was at 3, negative 16. But why is it negative 3? Because the formula, remember we said the standard way of doing it, f of x equals a x minus h squared plus k. So it's saying minus h. H is the x, part of the vertex. It's 3, so it would be minus 3. Now if x was minus 3, it would be plus 3. You see how that goes? And then we have a minus 16, so we just say minus 16. So this is vertex form. Now vertex form can help us when we're looking at doing a double translation here, a double shift. So you should remember from last video, when you see something like this, we have a horizontal shift. And when it's going negative, remember we said when it's going negative, you do the opposite you would think of doing. Instead of going to the left, you would go to the right. So here, if we go to the right, we're going to go here. Now the axis symmetry will be at 2. And it'll be up 3, right? So that's where the new shift would be, like that. Doing it twice. If you want to remember why is it 2 when it says negative 2, because you want to get 0. How can you get 0 here? Well, if you put x is 2, 2 minus 2 is 0. Simple as that. So let's try one on your own. All right, how would you do this one? Now all we're doing right now is the a is 1, so you don't even need to put the a there. We'll do, when a is greater than 1, we'll do more in the next video, in part 3. So what should we do here? First, let's make our parent function. Just sketching it out, right? Our parent function, roughly, there it is. Right? F of x equals x squared. So again, we have a plus 3, so we should go 3 horizontally, and down 4. So there it is. That would be our new graph. All right. So in the next video, we'll talk about when a is greater than 1, because when a is greater than 1, like we said, it's going to compress it. It's going to make it narrower. And if it's less than 1, it will make it wider. All right, great job.